Bismillahirrahmanirrahim. I'm Sul. I'm gonna explain about the experiment 1A, activity 1 to 3. Okay, we go first to construct a circuit SAM in the Labsheet in activity 1. We put the DC voltage, DC source, rotate the resistance, and connect it. We change the resistance value to 100 ohm, and we connect the voltmeter to the node before and after resistance 1. And we connect the ammeter between the DC source 10 volts and the resistance, and we generate it. Not generate, simulate. Okay, we get the data value on the circuit. We get 101 milliampere, and on the resistance 100 ohm we get 10 volts. We change the resistance value to 150 ohm. We simulate. And get the current value 67.66. The voltage value doesn't change, and we change the resistance value to 200. We simulate and we get the current value 51 milliampere. We change the R value to 300. We get a current 34.33 milliampere. We change to the final value of the resistance, like 1K, and we simulate it and we get the current value 11 milliampere, voltage value 10 volts. We go to the activity 2 DC. Actually the circuit is same. We connect the ammeter between the DC source 10 volt and 100 ohm resistance. We put the internal resistance 15.5 ohm like in the Labsheet, and we connect the voltmeter between the two nodes before and after DC voltage. We open the generator interface. Okay, we simulate and we get the current 86.58 milliampere, and multimeter show the 10 volt of voltage. The voltage doesn't change because we use the one value of DC voltage. We change the 150 ohm, we get 60.42 milliampere, and the voltage doesn't change to 10 volt. We change to 200 ohm, we simulate and get the current value 46.40 milliampere, and voltage doesn't change. And change the resistor value to 300 ohm, and we get the 31.696 milliampere of current, 10 volt of voltage. And the last one, we change to 1k resistance, simulate and get 9.84 milliampere of current and 10 volt of voltage. Okay, we go to activity 3 in DC source. Construct the circuit. The circuit is same like activity 2, but the difference between activity 2 and activity 3 is how we measure the error. For this activity 3, we measured the error in circuit and current reading. On activity 2, we detect the error on the resistance, and we prove in the Labsheet lah. We connect the resistance to the multimeter that mewakili emitter, and we put the same resistance, internal resistance 15.5 ohm, and we put another one multimeter to measure voltage, and we start to the first value, which is 100 ohm. We simulate and get 86.58 milliampere, and the voltage 10 volt. Stop simulate. We change the resistance value to the 150 ohm, and we get the current value 60.423 milliampere, and voltage 10 volts. And the last one, we change the resistance value to 300. We simulate again, and we get the current value 31.696 milliampere, and the voltage 10 volt.
First of all, I put all the components needed in this activity and arrange them like the diagram given. Next, I click the multimeter to set the measurement value as ampere. For the second multimeter, I set the voltmeter resistance as 10 kilo ohm. We change it to 10. And for the resistor, we need to change the value to 150. And we will run it to get the value. And for the first test, we got 10 volt for the UL and 67.667 milliampere for the IL. And we will change the value of resistance to 300 and run it to get the value. And we got 34.333 milliampere for the IL and still 10 volt for the UL. Lastly, we change the resistance value to 1K and got the measurement 11 milliampere for the IL and still 10 volt for the UL. Now, let's look at the activity 1 for AC circuit. Firstly, I will put all the components that we will use in this activity and arrange it just like the diagram given in the lab sheet. Now, click the resistor and change the value to 210 ohm. Then click the AC power source to change the value of frequency to 50 Hz and 10 volt for the voltage value. Let's bring this out so we can see the measurement value. And we can run this circuit. As you can see, we got 47.6 milliampere and 10 volt when the resistor is 210 ohm. Now we will change the resistance value to 390 ohm and we will get 25.6 milliampere and 10 volt when the resistor value is 390 ohm. Then we will change the resistance value to 470 ohm and we will get 21.3 milliampere and 10 volt. And lastly, we will change the resistance value to 860 ohm. And as the result, we got 11.6 milliampere and 10 volt.
Hi, Assalamualaikum. My name is Nur Azura. I'll be explaining about exercise 1B, activity 2 and activity 3. So, for activity 2 AC, first of all we need the AC power. Place it at the platform, and then we need ground 1 for the voltage, ground 2 for the resistor. We need resistor, 2 resistor, resistor 1, resistor 2. After that, we rotate the resistor 90 degree clockwise. Rotate the resistor 90 degree clockwise, and then we connect them in parallel, in series. In series. Connect them. Connect the voltage to the ground. Connect the voltage to the resistor load. There you go. Alright. And then we need to put the emitter probe across the voltage to the resistor, and then we put voltmeter for each resistor, because we need to observe the voltage across each resistor. There you go. Okay, we put the second voltmeter. Don't forget to set the voltmeter into sine wave, because this is AC, right? Okay, place the second voltmeter, connect the positive, connect the negative. Okay, set it to the sine wave. Alright, let's put it this side for the result, and then we change the resistor value. Oops, I just moved the value display. We change the resistor value to 210. Wait, I forget, that's why I stopped. And then 390 for the second resistor, and then we change the voltmeter voltage 10 volt 50 volt RMS and 50 hertz frequency. Alright, done. And then we run the simulation. There you go. Observe the IRMS 83.3 milliamp. Voltage across R1 is 17.499 and the R2 is 32.499. And then we change the resistor value 390 and 470 ohm. And then we run again the simulation. We observe the IRMS 58.1. The voltage 1 is 22.673 and voltage 1 22.674 and voltage 2 27.325. And then we stop the simulation, and then we change the resistor value again to 470 ohm and 860 ohm. There you go. And then we run the simulation. We observe the IRMS 37.6 milliamp. V1 is 17.668 and V2 32.33 volt. Stop the simulation and change the resistor value again to 110 and 860 ohm. Run the simulation, we get the IRMS 46.7 milli, 9.813 volt V1 and 40.185 V2. Okay, let's move on to the second activity, the third activity of AC. Let me change it first. Okay, put it AC power on the platform, ground for the voltage source, ground for resistor, and another ground for resistor, because we use resistor in parallel. So we need resistor 1 and then resistor 2, and then we rotate the resistor 90 degree clockwise. There you go. That's how you do it. That's how you rotate the resistor. And then we move it a little bit, and then we connect the voltage to the resistor, connect the resistor 1, resistor 2, and then we connect voltage source to the ground, connect the resistor to the ground, connect the resistor to the ground, and then we put voltmeter across one of the resistor, because as we know, voltage across resistor in parallel is just the same. And then we set it to the sine wave to get the AC value. After that, we change the resistor value 210 ohm. The second resistor is 390 ohm. And then I forgot. We put emitter probe for each resistor, because we need to observe the current for each resistor, because it is different. And then I forgot what else. Let me check. We need to change the voltage source 10 VRMS and 50 Hz frequency, and run the simulation. So you observe the IRMS 47.6, 25.6, and the voltmeter is showing the value of 10 volt across each resistor. And then we stop it, and then we change the resistor value again, 390 ohm, and then 470 ohm. And then we run again the simulation to get the result. IRMS, as you can see, 25.6 milli, 21.3 milli, and the voltmeter showing 10 volt across each resistor. Start the simulation, and then we change again the value, 470 ohm, and then the second one is 860 ohm. And then we run again the simulation, and we see the IRMS 21.3 milliamps, 11.6 milliamp, and the voltage is 10 volt. Stop the simulation, and then we change again the resistor value to 1210 ohm and 860 ohm. And then we run again the simulation to get the result. We can observe the IRMS 47.6, the IRMS 11.6 milliamp, and the voltage is 10 volt. Okay, I think that's all from me.